We just had an absolutely massive plasma filament launch from the sun. As we can see here, we've been having some plasma filaments launch from the sun over the past few days. They have been getting progressively larger each and every time. And now we have the largest of the batch. This, in fact, may be the biggest plasma filament launch that we have seen in years. That's what some other space weather forecasters are saying. And just look at the sheer size of that. It's not just one, two, it's actually multiple. We see this main one here, but also some activity looking like it's originating from the far side connected to this at the same time. Now, if I click off this most recent video from today, here we see the other plasma filaments that have been launching from the sun. So let's go back to the beginning of May 5th and so we can put this into greater context, because we had a whole bunch of plasma filaments launch from the sun. These are these bundles of plasma that sit out just off the surface, kind of stretching into the atmosphere of the sun, the corona. We see those launched off, and then we got a really big one that launched off here as well. So in general, we've had a lot of activity. This is actually the plasma filament that is destabilized just recently because it's moved on in its rotation. Now that is finally launched off. For people that have been watching the channel for a while, or anyone that's savvy with space weather, you may be asking, is this Earth directed? And it does not appear to be Earth directed at this moment in time with the available imagery that we have. It looks like it's mostly going to the north. But we just had this happen in the past few hours as I'm recording this live. Hello and welcome everyone to the live stream. I'm your host, Stefan Burns, geophysicist, space weatherman, and more. And we also have some other strange things happening on the sun right now as well. So if I switch over here, we see our 211 angstrom view of the sun, and we have a huge coronal hole rotating onto the Earth-facing side of the sun for its 9th rotation. This is a coronal hole right there. That one was, moderately large. We see some other coronal holes here. Our 211 angstrom view of the sun shows them really nicely. These areas in the solar corona where there's not much plasma, the density is lower, the temperature is lower. But if I pause it all the way at the end here, we'll see it's just now starting to rotate in. I did a live stream on this, or a video on this recently. It looks like it's quite large. We have some imagery of the far side of the sun exactly right now. We're very lucky to have that due to Solar Orbiter Probe. But this is just starting to rotate into view. By itself, it's not exceptionally abnormal, but it has been a very large coronal hole. Rotation number 7 was huge. Rotation number 8 was huge. Rotation number 9 is also looking very significant, and it's going to be going geoeffective right as we have some critical planetary geometry across the solar system on May 17th, which is also the day of the Uranus-Cazimi. And as I'm filming this, we right now have a full moon. So happy full moon, everyone. Maybe that's why I'm a little bit of a lunatic and I'm up so late right now. So that is happening. We have the coronal hole soon to rotate into the geoeffective position where this one effectively is. That one will take its place in about five or 7 days or so. It looks like it shifted its position a little bit, but we've also had this plasma filament destabilization today, both of them just epic in their scale. This coronal hole that we've been having with rotation 7, rotation 8 has been absolutely epic in its size. Very likely the biggest coronal hole we have had on the sun in a decade. And this may be a similar figure. Its plasma filaments are a little hard to track as it relates to solar activity versus, let's say, like a big solar flare. There's a good record log of that. But this is an absolutely massive plasma filament that launched from the sun. And this is all happening while sunspot numbers are plummeting. So we can go to our data from the Royal Observatory Belgium. They've been keeping track of sunspot numbers for a very long time. And we have an estimated sunspot number right here. So the estimated international sunspot number, and the estimate's always for the current month, and then they finalize it for the month that was just prior. So here we're looking at the past 30 days for sunspots, April 2025 to May 2025. And let's actually just move over to our data graphic right here so we can look at this a little bit more precisely. And we see that we had our low in April going to about 80 or so, right? This is 100 sunspots, that's 90, that's 80. We drop below maybe to 75, charge all the way up to 200. Meanwhile, the month with the most sunspots, we'll look at this data next, but the month with the most sunspots thus far in solar cycle 25 has been August with about 215, 216. It's like right in between them. So we got to 200 at the very end of April, but look at how we plummeted. All the way down below 50 here. That's maybe like the 1st or 2nd of May. I think that's May 2nd, I believe. Then we got just barely to 100, and now we are just struggling around 80. And in fact, our average number there is below 80 because we see this is 100, 90, 80, and our average for the month thus far is below 80, which is a precipitous drop in sunspots. If we put this into context of not only solar cycle 25 right here, but the other two solar cycles, we can see just how dramatic of a drop this is if that estimated sunspot number is to continue and end up being the final average for the month, which there's some evidence that it looks like it's going to be. We'll look at that next. Here's solar cycle 23, solar cycle 24. This is the 2010s. This is the early 2000 period, you know, the maximum, at least what I'm talking about, 2000, 2001, 2002, basically. This is like 2012, 2013, 2014, and now solar cycle 25. We are in solar cycle 25 maximum. This peak right there, again, is August. And as they say with solstice and these different periods on the planet, it's when you have in the northern hemisphere, for example, a solstice, or the southern hemisphere with the winter solstice, it's when you have the most light that then you have the transition of the cycle, and now the sun will start to set earlier and earlier and earlier. And so that's effectively the same symbology there as well. Very unlikely that we're going to get a sunspot number peak higher than that of August for solar cycle 25. This is being the monthly count of 216. So there may be a second kind of wind where we go up again in our sunspot numbers. We see that with solar cycle 23. We see this kind of double peak structure. We see that with 24, double peak structure. Very unlikely though that will break 216. So that was our maximum sunspot number. For solar cycle 25, we're just going to keep going down, very, very likely. And so if I zoom in specifically on solar cycle 25 here, and we'll go back to our more zoomed out view. If I zoom in specifically, we see that our values have been hovering just under 150 now, or right, I guess you could average the past 1, 2, 3, 4, 5, 6, 7 months now as 150. That's about a good average right there between these ones up above and one below. But this new count, if it stays, let's say 80, it's going to be all the way down there. Massive drop in the sunspot numbers. And so perhaps that is one of the factors that's contributing to some of these strange things happening on the sun with the plasma filaments that have launched off, and that huge coronal hole that we've been having dominating the sun, and you don't have sunspots under a coronal hole. So once the coronal holes go away, if they do, we should see a rebound in the sunspot number, though again, not probably exceeding that monthly count for August of 2024, which was 216, but we should see a rebound. And in fact, that is what we see with our sunspot record across some of these solar cycles. So you go back again to solar cycle 23 and 24, we see that we had our peak there, and then things dropped to maybe 120 or so right there. We had some of these drops, and even solar cycle 24 had some of these really significant drops down to even 50, though this was an anomalously weak solar cycle. But still, you see actually quite a few drops where it really went down, and then, for example, this one, a few months later, it reached its second peak. So with the dynamic we often see is that when things really precipitously are volatile and, let's say, drop really quickly, or the inverse, rise really quickly, that's when you get a big swing in the opposite direction. So if May does clock in at around, let's say, 80 or under 100, that's almost almost absolutely certain is that the sunspot number will be under 100 for the month of May. Unless something really radically changes with the sun, a new bunch of solar flux pushes out, we're almost certainly under 100. I think we'll probably stay at around 80, if not even less. That number is going to be like down there. That's going to be a huge drop in the sunspots. And then I would not be surprised if we were to rebound out of that back to that 150 range. But that is speculation. Now we can look at our current sunspots to see why our numbers are so low. We had some just rotate out. We see a couple sunspots here on the western limb. You know, you can barely see that group there. Very, very minor activity. We do have a new sunspot group rotating in. This one's looking, you know, it's moderately large. Nothing to write home about yet. We'll see if it does anything. Flare activity has been very, very low. But if I go over to, so remember what this looks like. This is our Earth-facing side of the sun. Now we can go see what the far side of the sun looks like. Because right now our solar orbiter probe is exactly opposite on the other side of the sun. So I have this link in the video description. You can check this out. And solar orbiter is not always on the far side. So we can see what's happening exactly on the opposite side of the sun from the Earth, which allows us to have a better understanding of the solar cycle in general. If you go to our intensity diagram for the far side, we see a few more sunspots, but not that many. And besides this group right there that will soon rotate onto the Earth-facing side, these are all near the central meridian. It's going to take them a week to get there. We don't really see anything following up behind them too much except the sunspot that just rotated out of view, 4079, which just had its biggest flare actually on the limb, finally decided to wake up. So, I mean, as you can see, looking at this, there's really nothing to write home about as it relates to sunspot numbers and things increasing. And so I think it's very likely that we're going to see this sunspot count for May be the lowest that it's been in a long time, going all the way back to, I mean, God, let's check it out. We have to zoom in again to do that, but going all the way back to perhaps 2022, November 2020, let me go over here. November 2022 was 80. If you look right here, November 2022 was 80.5 for the month, according to NOAA. Since 2023, since December 2022, but since 2023, we have not basically had a sunspot count below 100. And so this will be a dramatic shift as it relates to sunspots. And there is a connection between sunspots and earthquake activity. So that is interesting. Something else I wanted to mention is the fact that we've been seeing some anomalies in the Schumann resonances just in the past couple days. So, but before we do that, let's look at our earthquake activity. There's also a connection between earthquakes and coronal holes. The evidence for that is quite strong. There's more research that needs to be done, but we see that right when rotation number 7 at this huge coronal hole on the sun went geoeffective, we had this seismic burst here. Rotation number 8 brought more seismic activity. We now have cooled off. As we see here, our activity right now is only moderate to low, but we have rotation number 9 coming into that geoeffective position quite soon. And so it looks like this may continue as a result of that, because this coronal hole for the 9th rotation is looking again very, very large. And this is perhaps, that perhaps is being indicated, by the fact that we're seeing some anomalies in the Schumann resonances right now. I just want to quickly get your eyes on this. I'll probably have to do a dedicated video on this. I was actually going to make that video today, and then I saw the solar activity of the plasma filaments. I decided to redirect my focus. And I did create a graphic kind of highlighting these anomalies a little bit more clearly for you all. So let me pull that up as well. But to get your eyes on them, to start here first, we see our most recent data from the Space Observing System out of Tomsk, Russia. This is measuring the vertical electric field. If I scroll over, we see it goes from 0 to 40 hertz. So we have 0 hertz at the top of this spectrogram, which is what this is called, 40 hertz down below. We have our time. This is in universal time plus 7. We're looking effectively at the vibrations within this vertical electric current going from the ground surface up to Earth's ionosphere, the uppermost part of the atmosphere. It's about 1% plasma, is able to host these electric currents. This is the global electric circuit. And so they put a color to these different intensities across this frequency range of 0 to 40 hertz. And within this frequency range is where the Schumann resonances live, which are Earth's natural resonant energy fields, these standing waves. They connect to our brain waves, our heart rhythms. They could be a collective consciousness for the planet. There's some very interesting stuff as it relates to Schumann resonances. When you take, for example, any sort of entheogen, your brain waves drop right into that Schumann resonance range, especially mode 1 there at 7.8 hertz on average. And also that occurs when you naturally go to sleep, especially REM sleep when you're dreaming. So very interesting stuff right now. Regardless, look here, see that anomaly right there, like this interesting shape, and then we get this one down below. We also get this little energy burst right there. And then if I go over even further, you see that we have another kind of waveform right there. We see another one right there as well, like this. And in our most recent data, we have the same pattern repeating here, going up like that. Then also this one going down like this. And this one is slightly higher now in the frequency range than the last time. It's just slightly higher. So let me pull up the graphic I made so you can see this really clearly. And I'll step off to the side. But you'll notice that there are some slight differences between them. So this could be related to some sort of, for example, maybe like the power lines, or there's some sort of power supply that's creating this electromagnetic noise locally in the area. This could, though, be perhaps some sort of global effect, because we've seen these sort of anomalies with these sort of structures and shapes and intensities before very high magnitude earthquakes. So I don't know what these are exactly, but with this tracing there, you can see these shapes a little bit better. And so we have just kind of a very unusual pattern right now in the Schumann resonances. Also this one right there. And these are kind of a mirror of each other. So again, I don't know if that's some sort of local power disturbance or whether that is some genuine global electromagnetic signal related to some Earth geophysical event like an earthquake. But we know these coronal holes, they seem to really load the Earth with a lot of energy and can trigger these high magnitude earthquakes. There's at least a good amount of support for that. And now we're seeing anomalies in the Schumann resonances. And the last time we saw these anomalies, there's actually a malfunction with the station. I did that live stream that reached a lot of people. That turned out to either be a malfunction or they did something crazy with the data, but we didn't get anything from that. So I think it was just a data malfunction. But this is definitely a little bit of a different scenario here, where we see these very clear anomalies in the Schumann resonances. If I switch it back to our display capture, you can see them without the markings here. And so this is data that's rolling in. I'll keep you up to date on this. I kind of want to see more of this before I make any clear claims. But it also, with these things, sometimes when we have seen these anomalies, the earthquakes follow pretty quickly afterwards. And so it's important to jump on top of this, which is one reason why I'm doing the live stream today. We can check our most recent earthquake activity to see if anything's popped off like anomalously during the live stream. Nothing has. We've only been in like low magnitude 5 earthquakes for the past few days now. Again, if we go back here, we see that we've only been at low and even like low moderate, like low activity right there. So nothing really all that wild happening as it relates to Earth geophysics, but we do seem to see overall that when sunspot numbers are low after a big loading phase, that is when we get the most earthquake energy release, because these sunspots on the sun, they release a lot of high vibrational light, like X-ray light, extreme ultraviolet light, much more so than just a calm sun with a calm surface where most energy being released is more infrared, visible, and ultraviolet light. And so sunspots, they have an effect where they strengthen the global electric circuit because of their light that they emit these specific frequencies. And then it seems that when sunspot numbers go down and that light flux diminishes, that is when the Earth then has these earthquakes and energy can come up from deeper within the planet, the crust, perhaps even deeper down than that. We're seeing some interesting things as it relates to the hot spots around the globe. I've discussed that. I don't think it's anything super anomalous, but interesting nonetheless. So that is what is happening with the sun right now. We have this coronal hole that is active. Well, not active, soon to be active. This one is active right now. Let's actually look at our real-time solar wind in just a little bit, but that is going to be active probably within about a week or so. And that is a very large coronal hole. So that is the first strange thing you could say. And then we had this plasma filament here, which was absolutely epic in scale. You do not see that every day. That is wild. And so I wanted to get on and talk about that and get ahead of it, because in general now, since the beginning of May, sunspot numbers have gone down, but we've had a ton of plasma filaments launch off, just a lot of activity in other ways. Not really many solar flares. The solar flare activity has been very, very low, but some of these other things on the sun have been very, very active. We go over to our real-time solar wind. We see that we had this coronal hole high-speed stream impact. It was very, very muted. I do want to just fill people in. I made a forecast for that coronal hole high-speed stream in these two dark plasma filaments that launched off on May 5th and the 6th. I made a forecast that that storm impact would be stronger than expected. And, well, it wasn't that strong. Maybe it was stronger than some people expected, but in general, we didn't even get to a G1 level for that storm. So I was a little off with that forecast. I apologize for that. That's space weather forecasting for you. You're never going to be absolutely perfect. We did, get some enhancement in geomagnetic activity and space weather conditions, but we did not have a significant solar storm from that. It seems that the Earth kind of slipped through a bit of a void in the solar wind because we had a bunch of stuff launch off from everywhere. I think I still have the video up here. Again, May 5th to the 9th, you'll see how many plasma filaments launched off. Not all of them Earth directed, but some of them were, and we seem to kind of slip through that, right? We just saw all that happen. We seem to slip through that pretty nicely. So I wasn't 100% accurate with that forecast, and just wanted to acknowledge that on the live stream. I do my best, and I hope you found that forecast valuable anyways. But I never gave a specific rating for the storm, G1, G2, G3. I just said it was likely going to be stronger than expected. If we go back though to our real-time solar wind, we see that it's actually been strengthening just over the past 24 hours. We are now at a value here of 12 for the interplanetary magnetic field. And back here, we never even got to values like that with the storm. We only got to like 10 at the max. And we even hit values of 13, maybe 14, 13 nanotesla. For reference, the normal strength is 5 nanotesla. So you go to 12 and now you're about 2.5 times stronger than normal. Though the southward component is positive. You need that to be negative. This red line needs to be in this location right here. See how they shade it purple there? When you have that, that is indicating a strong connection between the interplanetary magnetic field of the solar wind and also Earth's magnetic field, allowing for the plasma, this is the density that we have right there of the solar wind, plasma density, particles per cubic centimeter. That's when you can have that plasma get pushed into Earth's magnetosphere, the plasmasphere, and cause these geomagnetic storms. So right now the velocity is low. We see it's only about 400 kilometers per second. Density is about average at greater than 10. The solar wind strength is 2.5 times stronger than normal. And if we go back to our SDO graphic here, we do see that we have a very tiny coronal hole that will be in the geoeffective position. And NOAA's forecasting that's going to give us an enhancement of geomagnetic activity starting today, universal time, which would be May 13th. So that is right now starting to exert its influence, and we should see a solar wind velocity go up. Though again, if we look at this, it's a very, very tiny coronal hole. So that is the update for all of you today. I wanted to share that with you. Also, we've had some super thanks. So thank you, JP, for the super thanks. And thank you, Yuri, for the incredibly generous super thanks. Stefan, welcome to the new era. Just wait for the new Schumann resonance data. Yes, I'll keep you up to date on that as we learn more, because this is certainly unusual here. It could be related to some sort of power cycling. For example, like some of these geophysical observatories are run by solar power, and depending on the power inverter, it can create this sort of low frequency noise that shows up in the spectrogram. It's just contamination from a local source. This could be that. It also could be some global signal, because we see very similar structure to these anomalies here with pre-earthquake signals that appear in the Schumann resonances, which there is a rich body of research discussing. So yes, I'll keep you up to date. Thank you, Yuri, so much for the incredibly generous super thanks. Wishing all of you well. Please take care of yourselves, and I'll see you all very, very soon.